Today we take a look at section 4.7 on variation. We're going to be looking at the different ways that quantities can vary with one another. There are three types of variation that we'll consider in this section: direct variation, inverse variation, and combined variation. There's a basic equation for each that you will need to become familiar with. Once you become familiar with the equations, then it's a four-step process that you will go through to solve each problem. It's always best to leave any type of rounding to the very end of the problem. If you round somewhere in the middle of a problem, it will throw your final answer off. So taking a look at direct variation. For an equation of the form y equals kx, y varies directly with x is how we would read this. So when you see the word direct or direct variation in a word problem, I want you to keep in mind that you will be multiplying that variable x by k, and k stands for our constant of variation. It's giving us pretty much the rate at which these two variables x and y relate to one another. The proportionality constant is another name for it. So when you see the word direct in the problem, think about the operation of multiplication. You are going to be multiplying k times the variable. One of the simple examples I like to use, if we think about the amount of food we eat and how much we weigh. For most people, their weight is directly proportional to the amount of food they eat. The more food we eat, the more we tend to weigh. The less food we eat, the less we tend to weigh. So there's a direct relationship. As one increases, so does the other. As one decreases, so does the other. At what rate that happens, it depends on that individual. So there's a different rate for each person. So here are the steps that we're going to follow. Translate the problem into an equation. So we're going to read the statements that they give us and translate it into an equation. We're going to then substitute the values that they give us so that we can solve for k. So that's going to be the first thing we want to find once we have our equation. Find that constant rate of variation. Once we have k, we'll then substitute it back into the general equation so that we can now be prepared to solve other questions which present themselves in the same problem. So substitute k in the general equation and then use that general model to answer the question that they pose in the problem. So here's our first example, problem number 2 from your textbook. The length of a simple pendulum varies directly with the square of its period. This first sentence is what we're going to use to translate and get our equation. Now you can use the y and k, but it really helps to use letters that apply to the situation. So we're talking about length of a simple pendulum. So I chose to use L for length. Varies directly. So I'm about to put my equal sign and I know I'm going to follow it with k times a variable because it said directly. We multiply. Varies directly with the square of its period. Well, how do I represent the square of something? And since we're talking about period, I use the letter P and then raise it to the second power. If a pendulum has a length of 2.25 meters, so now they're giving us details. We came up with our equation, that's step 1. Now they're giving us details and we're going to use those details to help us find k in step number 2. All right, so if a pendulum's length is 2.25, so I plug that in for L, equal k, and it has a period of 3 seconds. We plug that in for P. So see how it helps to have the letters that apply to that problem, so I knew where to put the 3. And remember, it's being squared. So now we have enough details to find k. So 3 squared is 9, divide both sides by 9, and it so turned out that k was a terminating decimal. If this had been a non-terminating decimal, an irrational number, I would not round it. I would leave it in fraction form until the very end of the problem. Leave the rounding till the end, okay? So that we get the most accurate answer that we can. All right, now that we have k, we're going to use this in the general formula. So going back to our general formula from step 1, we're going to have L equals 0.25, which is now our k, times P squared. As we read on in the problem, you realize they're asking you another question. How long is a pendulum with a period of 8 seconds? So how long? We're looking for the length. So we fill in the 8 seconds for the period. Remember, that was the time. The period was the time there, 8 seconds. And we then simplify. 8 squared is 64. Multiplying, we end up with the length of that pendulum would be 16 meters. So here's an example of direct variation. Now let's take a look at inverse variation. This is the basic equation. Y equals k divided by x. So when we say that y varies inversely, we're going to think about the operation of division. You're going to be dividing k by a variable. The example I like to use here is the amount that we weigh varies inversely with the amount of exercise we do. There's an inverse relationship here. As we increase the amount of exercise, we tend to weigh less. As we decrease the amount of exercise, we tend to weigh more. Remember, in the direct relationship, as one increased, so did the other. As one decreased, so did the other. They went in the same direction. In an inverse relationship, notice that as one increases, the other decreases. The more I exercise, the less I tend to weigh. All right, so here's an example. We're going to look for the word inverse to know to divide. The value of a car is inversely proportional to its age. So we're going to translate this into an equation. Step 1. We're following the same 4 steps as before. So the value of a car, I chose to use the letter V for value. You can choose any letter that relates to the information they're giving you. The value of a car, V, is, so I know that's my equal sign, inversely proportional, so I know I'm about to divide K. K is a part of every single problem, okay? So inversely proportional to its age. So I'm dividing K by A. As soon as we see the word inverse, we put our K and then we look to see what to divide it by. In the previous problem, when we saw the word direct, we put our K and we look to see what to multiply by. As we read on, we see the details they gave us. If a car is worth $8,100, so that's the value. When it's 4 years old, so that is age. So notice I have 8,100 equals K divided by 4. So I'm going to use that information to find K. So because it's an equation with a fraction in it, I chose to multiply by the common denominator, which was 4. That canceled the denominator off on the right-hand side, and so here I get 32,400. So this is my value of K. Step number 3 then, we take that value of K and we plug it into the general formula so that we can then actually answer the question that they pose. So taking K, plugging it into the general formula, we have V equals 32,400 divided by A. As we read on, we see that they want us to find the age. How old will it be when it's worth 3,600? They gave us a value, and we're looking for A. So I plugged in the information here in blue, and then I proceed to solve. Realizing it has fractions in it again, I chose to multiply by the denominator, which is A, so that's what I have here in green. That cancels here. We get 32,400 equals 3,600A. We then divide by this to find out that the age is 9, or 9 years. So it'll be worth that amount of money in 9 years. When it is 9 years old, let's say. So that's an example of inverse. All right, let's take a look now at combined variation. When you see that the problem has both direct and inverse in it, you are dealing with a combined variation problem. So they may tell you that something relates directly with this and inversely with this. So for example, how much you weigh is directly proportional to the amount of food you eat and inversely proportional to the amount of exercise you do. Notice in that statement, I had direct and inverse. And so this is what the equation would look like. Here are a few examples of what combined variation might be. Again, notice K is a part of every problem. We always need to find that constant of variation. Anytime they mention the word direct, remember to multiply. Anytime we mention the word inverse, remember to divide. Take a look at this next definition, joint variation. When you see that they say that a problem varies jointly, I want you to keep in mind multiplication and the fact that you're going to multiply by 2 or more other variables. In direct variation, you just multiply by one other variable. But when they say that y varies jointly as x and z, you're going to have y equal to k times x and times z. So you're going to multiply by 2 or more other variables. Let's take a look now at number 13. The load that can be supported by a rectangular beam varies jointly as the width of the beam and the square of its height, and inversely as the length of the beam. So our first sentence is where we're going to get our equation from, and we're going to use letters to represent the different parts. Now at first I would have thought to use L for load, but then I realized that they have the word length in here and I'll want to use L for that. So it says the load that can be supported. So I chose to use S for support by a rectangular beam, varies jointly. So as soon as we see our varies, we put our equal sign and we look to see what operation are we about to do. If it said direct, we'd multiply. If it said inverse, we'd divide. And because it says joint, we are going to multiply by more than one item, 2 or more items. So K, remember, is always a part of our problem, varies jointly as the width of the beam, so we can use W for width, and the square of its height. So I'm going to use H and squared for that. And inversely, so as soon as I see inverse, I know I'm dividing what I have. So, and inversely as the length of the beam, and so I'm going to use L for length. So this is our equation. We're going to now look at the details they give us so that we can find K. So looking up here, this is my equation. Support equals K times the width times the height squared divided by the length. Now let's take a look at the details they gave us in the problem. A beam 12 feet long, width 6 inches, height 4 inches. Notice the different units of measurement. We're going to need to convert these to the same measurement. So remember that it's 12 inches in a feet, and so we make the conversion from inches to feet. 6 inches is 1/2 of a foot, 4 inches, 1/3 of a foot, 8 inches, 2/3 of a foot, and 5 inches is 5/12 of a foot. So now we're ready to fill in the information into our formula. So it starts off by saying that a beam 12 feet long. So we put in 12 for the length, width 6 inches. So remember that's 1/2 of a foot for the width. Height 4 inches. So that's 1/3 of a foot for the height, and square that. And that this can support a maximum load of 900 pounds. So we put 900 for the support. All right, so to solve this, you could go about this a few different ways. I chose to multiply both sides by 12. First multiplying the numerator, got 1/18. Then I multiplied by 12 to get rid of the fraction, and so I ended up with 10,800 equals this. Then I multiplied both sides by 18 to get rid of the fraction, and I ended up with K being this. Once you have K, remember you plug it back into the original formula, and then we now solve the rest of the problem. It says that we have a similar board with a width of 8 inches. So the width, remember, 8 was 2/3 of a foot. Height 5 inches, so 5/12 of a foot. Remember to square that. And we're looking for how long it is, okay? And it can support 1,200 pounds. So we need to know how long does the board need to be to support 1,200 pounds. This is important to whoever's going to be using this board to support them. All right, so let's take a look at what to do. I went ahead and order of operations, square this first. Then I went ahead and multiplied everything together on the numerator and got 22,500. Got rid of the fraction, multiplying both sides by L, and then found out that the length would need to be 18.75 feet. And so that's the answer they actually want us to turn in. But we still have to go through that 4-step process to eventually get to the 18.75 feet.